Hello everyone, this is the Bridge for Math speaking to you today on some more examples on functions. Yes, don't tease me, I'm a lot more casual than normal. Sometimes you run out of laundry, you know what I'm talking about. Well, today's question is a difference quotient question. And to be honest, very scary looking, shows up on most final exams in algebra, shows up on exams in calculus. We'll talk a little bit about how they relate. Very important thing to know, most people miss it because of a couple little things. And if you're paying real close attention to this video, I think I'm going to set you up for some serious success. So let's look at what is a difference quotient. It happens to be this formula right here. And I hope you see we got a scary looking F word. Yes, the fraction bomb. Look at this. When you have division for the fraction, that means quotient. See the subtraction sign here? That's difference. Difference quotient. So you can kind of memorize the name with the actual formula. Something really important to notice here, that you can't divide by 0. So what do we have a restriction on this letter H? Yes, it cannot equal 0. So the equal sign with a slash means cannot equal 0. When we look at this, you're probably pretty comfortable if x is a variable. Well, h is just a small, it's going to be a number typically, it's just a distance from your x variable. So don't let it stress you out. The h will actually just kind of work through. We'll actually never even tell you what h is typically until you get to calculus. And indeed, you hear me mentioning calculus again, so I want to talk to you about that. You know, sometimes you can say, well, I'll never see this again. Well, I would like to share with you, yes, you will. And many of you will actually have to take calculus, and it's a wonderful class. If you understand this now in algebra, you're going to be super strong when you get to calculus. But let's go back. What is this difference quotient telling you? You see this f again? F for function. F of x plus h is your input. Notice I have different colors here. A sexy red for h because h is so important to a difference quotient. Money green for x because x is going to be your money. Let's put it in here. X plus h is actually an input into the function here. X by itself is the input to this same function. And all that divided by h. Well, to find a difference quotient, you have to be given a function. You have to be given a function. In this case, the function is 3x squared. Now let's understand, remember we said functions are like machines? Well, imagine this being your Bank of America ATM machine. You put in $10, X is your input. You put in $10, what's your output? Well, the machine squares it, so 10 squared is 100. Then it multiplies it by 3. So you put in 10, you get out 300. Is that the bank you'd like to go to? I would. So understand that this is a function, it does something to what you put in. We are trying to find the difference quotient of this function. So all we have to do, literally, if you look at this, is we have to find 3 different puzzle pieces. F of x is given to you. H, just put in h. The only thing you really have to calculate is f of x plus h. That scares students. Don't let it scare you. Let me show you what it means. So the key here is to solve for f of x plus h. Notice it's an input. It looks like there's more than one thing you're putting in. It's literally just one input. And what do? You plug it in wherever you see the x. Do you remember that's how you plug things into the x? So the 3 stays there, the squared stays there, but x became what? X plus h, right? So now to solve for f of x plus h, all we have to do is FOIL. We have to square the x plus h. So x plus h times x plus h. If you remember foiling, first term times first term, x times x is x squared. Outer term, x times h is xh. Inner term, h times x is still xh. Doesn't matter which direction, because it's a commutative property. And h times h is your last term, which is h squared. So we did the foiling. We multiplied or distributed that out, whatever term you like to use. Now we have to make sure we finish by multiplying 3 by all these different terms. So you distribute the 3 through. And we end up with 3x squared plus 6xh plus 3h squared. 3 times x squared, 3x squared, 3 times 2xh. You see where it comes from. But this is the hard part of the puzzle. Can you take and solve for a function with a really strange looking input? And I know you can, and just practice and review this video. Well, let's put it all together. Let's put it all together. Remember the definition of where we started with the difference quotient. It's f of x plus h minus f of x divided by h. This is the difference quotient. This is what we're trying to solve for. We're going to plug in the pieces. This is the hard part that we had to calculate that we just did. The 3x squared and the h were given to us. Now let's just do the math. Do you see the 3x squared here? Subtract that 3x squared. They cancel out. What are you left with? 6xh plus 3h squared divided by h. Well, remember, our goal is always to simplify it as much as possible in math. So can you factor out h that's common to both terms in the top? Sure can. Pull out the greatest common factor of h. Remember, 6x times h gives you 6xh. 3h times h is 3h squared. So you factor out the h. They can cancel at the bottom now. And you're left with 6x plus 3h. That is your answer to the difference quotient. Practice this, get very good, because it does show up on future tests. Thank you for watching this video. Keep watching the Bridge for Math, and take care.